طيب بسم الله الرحمن الرحيم. Just to start, يعني this is the architecture we're talking about. We have covered last time security association. We talked about the security association in terms of what parameters, what is the primary key اللي هو ال SPI, and all the other fields. Today inshallah we are going to cover بقى security policy database, and then we are going to talk about some techniques. Eventually we're going to talk about IKE, how about to establish the security association. So as the assumption here is that security association will be a full data structure if it exists, but what if a traffic is coming in and there is no security association that maps to that traffic? So you need to establish a new one, in which case you need to have some handshaking at the level of the IKE in order to establish or create a new security. This is the traffic of the IKE اللي at the top here. So this is used to establish a new security association. So usually it's not going through. We covered these different parameters, security parameter index, which is the primary key. This is the main identifier of the security association, and we talked about all these other fields, and we mentioned the function of each one. So now we're going to talk about the security policy database, and we said that the security policy is the first gate for any traffic to come in. So any traffic that it's coming in, so you have a network, and this is like either a router, as we said, or a host, doesn't matter. If it's a router, we're talking about a tunnel mode. If it's a host, we're talking about the transport mode. So there's a traffic coming in. The first thing that I need to do is that we need to map that traffic that is coming in into some traffic outgoing. Call this outgoing traffic. Okay. So in order to map the incoming traffic to an outgoing tunnel or outgoing logical link, again logical link, because it's not a link, or it's not a connection, sorry, it's not a connection, because IP is connectionless. It's a logical one-way connection, as we said. So the first thing we need to do is just to map this incoming traffic to an outgoing secure traffic through the security policy database. Security policy database stores all the rules that are required to map this traffic to a particular outgoing traffic in IPsec. So the security policy database means by which the IP traffic is related to a specific security association. So in the security policy database, okay, we store the mapping, and from the mapping we get the SPI for the security association that we need to use for that particular traffic. ماشي كده؟ So based on certain rules, we say, okay, so this traffic fulfills this rule. Therefore, we're going to use this security association for that particular traffic. Okay? And the security association is identified by the security parameter index. ماشي? Through the security parameter index, we go then to fetch all the specs of the security association from the security association database, and then we build a tunnel to send the secure traffic. In more complex environment, there may be multiple entries that potentially relate to a single security association. So we can have multiple lines in the security policy database that use the same SPI or use the same security association. It's possible. ماشي? So based on, so I have, like, for example, a tunnel mode, okay, which is a tunnel between two routers or two firewalls, right? Any traffic that comes in will use the security association of that tunnel, right? So many traffic that are coming in may in fact use the same tunnel, in which case they use the same security association. Okay, so here I may have, if this is like a router, so I may have multiple traffic coming in. All of them, they will use that tunnel, صح? This is what happens in VPN. صح كده? So in VPN, if you have a tunnel, inside your home router, for example, any traffic that is going out from your house, it goes through that tunnel, in which case all this traffic maps to the same security association. ماشي? So that's logical. So each security policy database entry is defined by a set of IP. So now the security policy has two things. First, we have a set of rules, okay, and the traffic has to fulfill one of these rules, because if it doesn't, the traffic will be discarded completely. Okay, so there are three behaviors in IPsec. Three behaviors: a traffic that it's protected, which means it goes through the tunnel; a traffic that it's discarded, which means I don't have any rule that apply to this traffic, okay, or a traffic that it's bypassed. Bypass is a behavior. Bypass معناها ايه? I have a rule for this traffic, and the rule says that I should bypass the tunnel, which means I will send it unsecure. Right? So these are the three actions or the three behaviors. So in all cases, a traffic that is coming in has to fulfill one rule. Otherwise, it's going to be discarded. And we'll see this. ماشي كده? So the rule is defined by criteria. Okay? This criteria could be the local IP address, the remote IP address, the port, the protocol, whether it's HTTP, TLS, TCP, whatever. Okay? So I have a bunch of, we call them selectors. So the selectors are set of criteria. Each criteria may have a combination of multiple fields. Yani all the traffic that is coming from this IP address will go through the tunnel. But all the traffic that is coming from another IP address will bypass the tunnel. Okay? أنا حر. ماشي كده? So we call these selectors, and we'll see how this looks like. طيب, these are used to filter outgoing traffic. Okay? filter هنا, the filter has زي ما قلنا three functions: protect, bypass, discard. These are the three possible actions. Okay? So how does this بقى look like in details? Architecture. So these are the entries that might be included in the security policy database. So I can have, this is the criteria of the selectors بقى. ماشي? So I can have some criterion on the remote IP address. So any traffic that goes to this particular remote IP address will follow certain behavior, whether this behavior is bypass or discard or protect. ماشي? And this remote IP address can be defined either single IP or multiple or wildcard. صح? If I put a star or asterisk معناها ايه؟ It's going to any remote host, any remote IP host. ماشي? Same thing applies on the local IP address. So anything that comes from this local IP address will follow certain behavior. Or anything that has a next layer protocol. Next layer protocol we call it ايه بقى اللي هو ايه؟ اللي هو above IP. ماشي؟ TCP مثلا, TLS, things like that. So any incoming traffic, regardless, I could have هنا remote IP asterisk and a local IP asterisk. So anything coming from any source to any, but it has مثلا a traffic that uses a protocol TCP. So all the TCP traffic will have to go or follow certain behavior. ماشي كده? Or a name, username. I have access to the username. I could have access to a username. Okay, so I can put a criterion on a specific user. So, for example, I can apply مثلا a certain rule on any username that's outside the organization will have to go through VPN. User IDs that inside the organization, we don't have to pass them through the VPN tunnel and so on. ماشي? Or local and remote ports. Ports identify a specific application endpoint. Okay, the port identifies a specific application endpoint. As we said in network 1, if you even open multiple tabs on the browser, each one will have separate port, although all of them they use HTTP, صح? But each one will have a unique port. So I can specify a rule based on a certain application endpoint. ماشي كده؟ Here in the ماشي كده؟ Right. So this is how the security policy database might look like. So I can have a traffic that uses UDP on a specific local IP. So this is coming from a specific local IP, and it uses a particular port. So I can have a combination. So this, we call this a selector. ماشي? So a selector is a combination of all the fields that we talked about in the previous slide. And any remote IP. So it doesn't matter which IP destination it's going to, but the destination IP address is 500. Why? Because port 500 is used usually for IKE traffic. And as we said, IKE traffic is used to establish security assertion. Okay? So in that case, the behavior is bypassed because I don't have to use, or I should not use, a security assertion to build a security assertion. فهو IKE traffic is used to establish or to create a new security assertion. So the IKE traffic does not use a tunnel in that case. Same thing, so anything that uses ICMP is used, as we talked in network 1, is used to report error messages, okay? So in that case, we use it sometimes for ping, trace route, okay? So in that case, I don't have to secure that particular traffic. So again, it's bypassed, and it's used for error messages. And so on. So any traffic that uses any upper layer protocol that comes from this local IP address, because probably this security policy database is for host-to-host communication. So anything that comes from this local host address and it goes to this particular remote address, now I need to protect. And the protection now uses a ESP for transport mode, because it's host-to-host communication. ماشي كده؟ So, and so on. So for TCP, for example, from this local IP to this, okay, I'm going to protect, and this is to encrypt. For another TCP that goes to 443, what is this 443? حد فاكر؟ HTTPS. HTTPS. إيه؟ لا. 80 is HTTP normal. So in that case, yes. So in that case, I need to protect. But HTTPS already uses TLS, right? Or SSL. We'll study this in the next chapter. So in that case, I don't have to repeat the job. So in that case, I can bypass. واضح كده logical? So that's how it works. But if I don't have a specific protocol, I can discard. And this might happen, for example, for if you مثلا try to address or to try to access مثلا a host inside QU from outside. So in that case, your local IP is not identifiable inside the organization. So in that case, I will discard. ماشي? So this happens to our traffic if we try to try to address internal server inside queue, but from outside. Okay? So the only way for you is just to try to use a VPN. In which case a VPN will allow you to get an internal IP address inside QU. So your local IP address will be identifiable in that case as an internal IP inside QU. In which case you will apply to one of these rules. But otherwise, if your IP is from outside, it's not internal, you should not be able to access any server, and in which case your traffic will be discarded by default. ماشي كده؟ In ايه؟ Star معناها any application endpoint يعني. Okay, regardless of the application. Star هنا معناها wild card.
In the protocol we have star.
Yes.
Any protocol.
Yes, from any upper layer protocol above IP يعني. Any protocol above IP, okay, from a specific local host, I can choose to discard. ماشي? And so on. Or I can bypass. ماشي? these are examples of some rules. Type. So how does بقى the logic work? So here we have the two flow charts. So again, we have a host or a router here, and there is an incoming traffic. So we call this outbound traffic. So the logic for this outbound traffic follows this flow chart. ماشي? So between this and another, again, host or a router on a remote network, we have بقى what we call the tunnel. صح كده? We have the tunnel, right? So this tunnel has entry point and exit point. صح? So the entry point, we call it outbound, which follows this flow chart. And here we have the exit, which follows another flow chart that we'll talk about in the next slide. Okay? So now we have many incoming traffic. Okay? And then we need to map this incoming traffic to this tunnel, whether by using action of bypass or discard or protect. And in the protect, I need to say or specify a flag, whether this is ESP or AH. ماشي؟ For اللي هو for encryption and for authentication. ماشي كده؟ طيب, so the logic is simple. It's logical. يعني the first entry point to any traffic is to search the security policy database. Either I have a match or I don't have a match. And as we said, any incoming traffic has to have a match. That's why we need to have the wildcard. So the wildcard is supposed to fulfill يعني many of the traffic. But again, we might have a traffic that does not have any match in the security policy database. So if that ever happens, the default action is discard. We have to have a policy for any incoming traffic, and it's the function of the network analyst or the security analyst يعني, to specify these rules in such a way that, that any traffic has to have a rule. Otherwise, the default is discard. ماشي؟ واضح كده؟ So if there is a match, now we're talking. Again, if there is a match, that doesn't mean if there is a match that we will not discard, because one of the potential actions is also to discard. If we have a specific action in the security policy database that says discard. So we determine the policy. If the policy is discard, خلاص we'll discard. Otherwise, the policy is to protect or to bypass. Bypass سهلة. Bypass, I will send it over IP. I don't have to pass it through the tunnel altogether. So I will send it IP. I don't have to include any ESP header or AH header or nothing. Okay? I don't have to search for security association. The traffic is sent as is. And hopefully it has TLS or something to guarantee its security. Okay? But for me, the rule is easy, is bypass. Bypass معناها send IP على طول. So I will add IP header بس. ماشي? Add IP header. If it's protect, then yeah, that's good, but we need to protect this traffic based on a security association. ده مهم جدا بقى. So here, if it's protect, here we need to look for, طبعا احنا we have a rule that applies to this traffic. From the rule we have protect, and the protect has the SPI. In the security policy database, we store the SPI of the security association that we need to use for that tunnel. Okay? So the assumption here is that if there is a rule that fulfills that traffic, we have an SPI of a security association that applies to this traffic. If we have this SPI, we'll search in the security association database. Okay? Using that SPI. SPI is the primary key for the security association. So SPI will get you only one security association, or as we will see, if you are using ESP and AH, in that case you have two. So security association, قلنا طبعا AH is optional, صح? We talked about this. Because in IPsec version 2, we don't have to use AH. AH is optional. But if you have both ASP and AH, then you need to have a security association for ASP and security association for AH. Okay? So in both cases, you have to search the security association database. If you have a match, معناها ايه؟ You have a security association that corresponds to this tunnel, in which case خلاص you will use بقى that security association. You will add both the ESP header and possibly, optionally, the AH header. Okay? And here بقى it depends. It depends where we add the ESP header, as we said, based on what? Based on whether it's tunnel mode or transport mode, right? If it's transport mode, we add the ESP header in a certain location. But if it's tunnel mode, we add it after the original IP address, original IP header, and then we have to add the outer IP header. We have to do two encapsulations. We will see how we do this. واضح كده؟ If there is no match, okay, now خد بالك. We have a rule, but we don't have a security association to use for that tunnel yet. What does that mean? This means that this is the first time you need to establish the tunnel for the first time. You have a rule in the security policy database, because security policy rules are permanent, right? But you need to establish the tunnel. In order to establish the tunnel, you need security association. So you need to build or create that security association for the first time. ماشي? You need to create that security association for the first time. Now we need to go to ITE. We need to go to ITE to establish that security association for the first time. We need to do بقى الهاند فاكرين اللي هو الهاند shaking? We did that حتى في network access security. We need to do the handshaking, establish بقى messages back and forth until we establish the security association, which gives you بقى all the technique that used for encryption, technique used for authentication, اللي هو message authentication codes, technique used for pseudo-random function to create IVs, to create dynamic keys, and so on, all of this. ماشي كده؟ ده ايه؟ اللي هو inbound. Okay, so outbound is for this. Inbound is for this. So now بقى the traffic went all through the tunnel, and now it needs to exit. ماشي? So here we don't do بقى encapsulation, remember, we do a decapsulation. Okay? So we are in the decapsulation direction going up. ماشي كده? And we need to exit the tunnel. Inside the tunnel, as we said, خلاص, everything is طبعا we need to keep the header in order to perform routing. Okay? But at the exit of the tunnel, you need to do decapsulation and send it up. You have to send it up. ماشي كده؟ You have to send it up. مثلا يوم عامل traffic, you send the traffic like this way, and the traffic is bypassed, صح؟ لما واحد يقوم ايه؟ traffic bypass معناها it goes away from the tunnel, صح؟ Goes in another بقى route. ماشي؟ So instead of doing this, one tries to send network injection directly. Okay? لا, I will have to check if indeed your traffic is to be bypassed. ماشي؟ So that هنا I looked up the SPI. Okay? كويس؟ If there is a match and everything is fine and it's protect, خلاص هنا بقى I will forward هنا at this point I will add the SPI in the header of the ESP. And I will have another SPI in the header of AH if I decide to use AH. Okay? So this is for the outgoing. Now we talk. So here we have an inbound traffic that is coming in at the end of the tunnel. So now we need to specify the packet type. If it's IP معناها ايه؟ معناها this traffic was bypassed. Right? It's at the end of the tunnel, yes, but this traffic was bypassed أصلا from the entry point of the tunnel. Right? So here I don't have to do anything specific other than I need to check another time the security policy database to make sure that indeed the rule is bypassed. ده مهم بقى. To avoid any network injection. Okay? Is network injection, somebody might bypass the tunnel and send normal IP traffic to the exit of the tunnel. Okay? So to avoid any network injection, we need to also perform another check on the security policy database to make sure that this traffic is indeed bypassed. مفهومة دي؟ يعني ايه؟ بدل the reason for this checkpoint. ماشي كده؟ If indeed it's bypassed, خلاص. If it's not bypassed, I'll discard. Okay, so this is for network injection. To avoid يعني network injection. Otherwise, if it's IPsec, معناها بقى it's tunnel mode, transport mode, and the action is protect. طب what if it's discard? If the action was discard, it will not come here أصلا. If the action is discard from the entry point, معناها خلاص the traffic will not come here. خلاص I don't have to address anything regarding discard here because it's already discarded. But if it's protect, معناها tunnel mode or transport mode, doesn't matter. Then بقى I need to check the security association in the security association database and get that security association to decrypt بقى. The security association at the end of the tunnel will allow me to decrypt and authenticate, which means I have to check the MAC, ماشي, and everything. And خلاص لو if there is a match and everything is decrypted and the packet is authenticated, ده مهم جدا. Packet is authenticated, okay, معناها the MAC is valid, خلاص I will send it up. ماشي كده؟ And everything is sent up بقى معناها ايه؟ sent to TCP بقى. الله يعينه بقى. خلاص؟
So Doctor, when it serves the security database based on what? On
SPI by the way is stored in the packet. SPI gets stored in the packet. I can't store them. هو هنا هنا come here خلاص. If I find the security association, where can I find the security association? Here I can read the packet and get the SPI and then look up the security association from the AH or the ASP header. Okay, and then here I perform all the decryption and everything. خلاص I decrypted everything. Now I have a TCP segment. ماشي. Even if it's TLS, for me I deal with TCP or UDP because TLS, as we will study next, TLS and TTLS حتى اللي هو for UDP اللي هو اللي بيسموه datagram TLS. This is used above TCP. We'll talk about this next time in the next chapter. Okay, so for me what I see as upper layer protocol is either a UDP TCP or ICMP. I don't see anything else. ماشي. خلاص I decrypt and send it up. My job is done. ماشي. اتفضل.
Can you repeat that?
Yeah. طيب مهم جدا بقى we talked about anti-replay window. فاكرين؟ We talked about this in the security association. So in the security association, we have 3 fields. We talked about this. اللي هو counter overflow, and the replay window or anti-replay attack window. Okay? The anti-replay attack window is usually 64 packets. Usually. Packets يعني. ماشي؟ معناها ايه؟ احنا قلنا why don't we have only the window of size 1? يعني why don't we expect everything to come in order وخلاص I'm expecting ما هو replay attack معناه ايه؟ ان انا I'm getting a copy of an encrypted authenticated packet and I resend it again. Okay? So in that case I can say okay, so I keep track of the current sequence. If you send me any sequence in the past, even if it's n-1, I will discard it. Why can't we do this?
Because IP doesn't guarantee that.
Bravo عليك. So because IP is unreliable and connectionless. تمام? So it is expected that even though packets will go into the tunnel with a specific sequence, that they will exit the tunnel in a different sequence. Okay? But there is a limit to this. Yes, IP is unreliable, كل شيء, but to some extent يعني. So that's why here the replay window is usually 64 packets. If it's more than 64 ده معناه ان الاي بي بقى is extremely unreliable. فهم experimentally again they evaluated that 64 is reasonable. Okay? طيب what if any incoming packet comes way in the past before the window? That this is بقى ايه؟ واضح بقى ان either IP is extremely unreliable or there is clearly a replay attack. ماشي؟ في الحالتين I'm going to discard the packet. فدي واضحة، اللوجيك ده واضح، تمام؟ طيب if the packet is coming inside the window, okay. So now I have to make sure that the packet is authenticated first before doing anything. Packet must be authenticated. If it's not authenticated, I will throw it away anyway. يبقى one, I have to make sure that the packet is authenticated. حلو. Packet is authenticated. Two, I check the sequence number of that and I see whether it's received already or not. So here in the window, I need to keep track which packet was received and which packet was not received, so that I don't duplicate. الدوبليكيشن ده معناه ايه برضو؟ There is a replay attack. Okay? So I'm getting a copy of the packet, I'm sending it again, معناها there is a duplicate packet. This is the whole point of doing this. And then I detect a replay attack. Okay? So if a packet is sent inside the window and it says it's received, I will discard the packet and I may actually raise the overflow counter to say, oh, okay, so there might be a replay attack. And the action to this is one of two: either to disconnect everything, okay, or to re-establish another security association, okay, in order to make sure that the replay attack is avoided. Okay? طيب if the packet marked not received, خلاص I will accept it. And I mark it received. طب what if the packet is here? No. Why? خد بالك بقى. هنا this is anti-replay mechanism. Replay attack is always for something in the past, not for something in the future. No one can get a copy of a packet that's in the future and try to replay it. بالعكس. This means that if it's an authenticated packet, this means that it's a valid packet. And in fact, this is the logic for sliding the window. Okay? So if you get, طب هتقول لي طب this packet was not received yet. Yes, ما احنا قلنا IP is unordered. Is unordered. You can receive this packet before this packet. Okay? So there has to be any window technique, as we talked about in TCP, and people who are taking computer engineering, we talked in Network 1 in logical link control, in data link. Okay? We also use window technique. Window technique has to have a mechanism for sliding the window. Okay? Yes, so this is bad the logic. If you receive a packet بس ايه outside after the window, okay? If it's after n plus 1, n plus 2, n plus 3, okay? This means that if it's an authenticated packet, I authenticate the packet طبعا using the MAC first, okay? And then if it's after the window, then I slide the window. ماشي كده؟ كده يبقى the window technique is complete. The window, I used the anything in the past before the window, discard regardless. خلاص. Inside the window, okay, authenticate the packet. If it's marked as received, also discard. If it's not marked as received, okay, accept. Accept معناها send it up. ماشي? If it's after the window, then we slide the window. Why? Because here the assumption is that replay attack is never done for future packets. It's done to previous packets, not to the future packets. ماشي كده واضح؟ تمام. So that's the logic. طيب, so here بقى this is nothing new in here. So here we have the transport level security and we have the tunnel mode or the virtual private network security. This uses the tunnel mode. ماشي? So if you establish, remember, if you establish a host-to-host secure communication, you need to establish طبعا security association, and security association, remember, security association is one-way logical connection. Okay? معناها if you want this host to communicate back, you have to have another security association. It's one-way logical connection. So this requires actually one security association in that direction and another security association in another direction. ماشي? And this is host to host. This is transport mode. For transport mode, the ESP header or the AH header is after the original IP header. We'll see how it's done. Okay? Here, but in the tunnel mode, we have a tunnel between one local private network and one remote private network, and you have a tunnel in between. And again, you have a security association for each of these tunnels, for one direction and another one for the other direction, for all of them. Okay? And the tunnel mode or transport mode is defined by a certain flag, as we talked about before, inside the security association. Just a flag to say whether it's ESP or AH or anything. Only anything that is for IKE traffic. If it's neither ESP or AH.
For each tunnel or each...
Yes, of course. You have to have a security association. So yes, you have to have one security association going and one security association backward. So for each of these tunnels, طبعا.
So each router may have more than...
Yes. You can establish multiple tunnels with multiple networks. حر. يعني imagine مثلا Microsoft organization or Apple organization. They have offices all over the world. And they have tunnels between all these offices. يعني you can think of it as a mesh network كده. Mesh network of logical tunnels between all the offices. And this is the way they have the intranet. This is the intranet. ماشي؟ طيب. So this is بقى ده مهم جدا بقى I removed from here the IPsec. IP version 6. Because IP version 6 is a lot more complicated. So I removed this part. But for here, we have IP. If it's transport mode, what happens بقى خد بالك كويس قوي. What happens is that's why it's called transport mode. So we add the ESP header before the IP header. ماشي? Before the IP header. It's like it's above. So it's above IP and under TCP. Okay, so in between TCP and IP. This is the transport mode. Okay, and this is used again for providing security between a host to host. ماشي? So the original IP is kept in that case. It's not touched. Which means that the ultimate host IP is still the same. And the local host is still the same. Okay? And this original IP is exposed. It's not encrypted. ماشي؟ مهمة جدا كمان. ماشي؟ طيب, so in that case بقى, what we do is that we add the ESP header, and here we have the ESP for authentication. هتقول لي فين ال AH? Okay? Here there's no AH. We are using ESP for both encryption and authentication. We said that this is bad for IPsec version 2 or 3. ماشي? As we said, for IP version 2, we don't have to use AH. It's optional. So we're using ESP for both encryption and authentication. So in that case, we have ESP authentication. ماشي? And the authentication, this is like the MAC يعني. So this is MAC here. اللي هو message authentication code. ماشي? So the authentication takes into consideration everything, including the ESP header. Remember that. ماشي? So MAC takes into consideration the ESP header for what? For calculating the signature. Remember the MAC, احنا بنعمل ايه في الماك? We calculate a signature based on a message, and then we we encrypt the signature using the key, صح? This is what we do. So in order to create the signature, you take into consideration the ESP header. But when it comes to encryption, you cannot encrypt the ESP header. يعني انت لما تيجي تعمل encryption للاس بي header, which includes the security parameter index. هشوفه انا ازاي يعني. ما انا I have to first get the security parameter index in order to know which security association to use in order to get the key to decrypt. صح؟ فالبيضة الأول ولا فرخة يعني I have to have. So the ESP header and the IP both have to be exposed. ماشي؟ ESP header in general is always exposed. Okay? Does not contain the key. It contains the SPI. This is the most important part in the ESP header. That's all I need. Okay? The SPI. From the SPI, I get the security association. From the security association, I know better how to get the key and use the key for decryption, authentication, and all of it. That's all I need from the ESP header, really. ماشي? So authentication. So to calculate the signature, I can include the ESP header, but for encryption I cannot. ماشي? So that's طيب. في بقى هنا بقى إيه? There is a very small part here. It's called the ESP trailer. Can anyone guess what this is used for? It's a tricky question. Why do we need to have this trailer? To indicate the end of the, you're getting close, but it's not exactly like this. We talked about in the first 3 chapters, we talked about a very important mechanism which is used to again try to confuse the cryptanalysis. We talked about a very important mechanism that we use for confusing the attacker who's trying to do some cryptanalysis. We talked about a concept called the padding. But padding here is not padding for packet alignment. Here is for confusing the attacker. We said that if the packet has a fixed size, this will make it easier for cryptanalysis, صح? So it's very important to vary the size of the packet so that the cryptanalysis can be more complicated. Okay? So ESP trailer, as we will see later, it's nothing but like some padding, and this padding is variable. It makes the size of the packet always variable, changes a lot. So any attacker who's trying to do cryptanalysis, he will be confused. ماشي? So now we have the header for encryption, we have the ESP for authentication, and this is for transport. For tunnel mode, we keep the original IP header after the TCP header. Okay, we leave it, and then we add the ESP header underneath the original IP header. Okay, so in that case, the ESP header under the IP, but it's always, remember, always the security comes after. If we do security from the IP layer, it has to be above. Okay, so that's why we need to add another outer IP header. Okay, and then this original IP header is totally hidden. Inside the header, you should not really see where it's coming from or where it's going to ultimately. The host itself is not identifiable. That's exactly why when we use the famous example that I talked about, when you use WhatsApp or something, so you see the voice quality is low because Ooredoo, they can identify the IP address and they can identify the service, and if you're using WhatsApp and so on, then خلاص, I can throttle, I can slow down the traffic so you feel like the voice quality is low, so you have to use normal phone calls. Okay? But if you encrypt all of this using VPN, all the header and everything is hidden, so you cannot see anything. You cannot see IP address, where it's coming from, where it's going to. You cannot see anything. So in that case, خلاص, you don't have to filter the traffic, you don't have to throttle, you cannot really throttle the traffic. Okay? So this outer header outer IP header is for the tunnel, which is in that case for router to router security, not host to host security, or host to router security. They use the tunnel mode bar. So host to router or router to router use the tunnel mode, in which case you have to encrypt the original IP and add another outer IP. ماشي? So in that case, as you can see, the encryption includes the original IP header. باينة. ماشي? And the authentication always includes the ESP header. Okay? And the same thing here. You have the MAC and you have the ESP trailer. So the only difference is here you have to do 2 encapsulation steps. One to add the ESP header and then to add another outer IP header. So that's how it's done from a layer perspective. So here you have the IP header. So in order to have IPsec, you have to embed the ESP header in between the TCP header and the original IP header. And the original IP header in that case is exposed. It's not encrypted. Cannot encrypt it. ماشي? And then you add the trailer and you add the authentication. For the tunnel mode, you have to do about 2 safe, IPsec, and then IP again. So you have to do the first encapsulation step, and then you have to add the outer IP. ماشي? So that's how it's done from the layer stack perspective. ماشي كده؟ Any questions of اتفضل.
The next IP header is the destination
router بالظبط. Here all I need to do is just to add the source router IP and the destination router IP. Okay. Not the host back. Not the IP of the host. I don't need that. بالعكس here the IP of the host is here and it's encrypted تماما. You should not see it. ماشي? You see it امتى? At the exit of the tunnel bar. So if it exits from the tunnel, you will have to do decapsulation. خلاص, I'll take the security association, I'll decrypt everything, and then I send another normal IP. In that case, you can see where the ultimate host is. But inside the tunnel, you should not see that. واضح كده؟ خلينا يا جماعة مش حد يفكرني.